Assalamu alaikum. Inshallah, in this video we'll continue our tutorial number 1 about extension spring. In this question, the extension spring shown in the figure has a full twisted loop ends. That is the type of the hook in the extension springs. يعني it doesn't matter the type. يعني at the end the solution will be the same. We have different 4 types: machine, half loop, open, raised hook, short twisted loop, and full twisted loop. In this question we have full twisted loop. Okay, it will not affect our solution whatever the type is. Okay, the material is AISI 1065 oil quenched and tempered wire. Okay, that is the heat treatment and the material of the wire. Okay, so this word OQ N and T is represent oil, quenched, and tempered. Okay, that is a heat treatment process. يعني a rapid cooling, then softening by tempering. Okay, tempered wire. Okay, so this information will help us in to find different things as we saw in the previous video. So I will use this row in table 10.5 for oil tempered. Okay, also here he mentioned O, Q, and T. I will use this one in table 10.4, and here he said also here tempered, so I will use this row in table 10.7. Okay, the spring has 84 coils. Okay, so the number of body coils, so this one is NB, is 84 coils, and is close wound. We said in the previous video that close wound means when extension springs are made with coils in contact with one another, they are said to be close ones. So they are in means that they are in contact with each other. Okay, with a preload that caused the close one, the preload Fi, the initial tension, is 16 pound force. Okay, find the closed length of the spring. The closed length of the spring means the free length before, yani when it was closed. Okay, before the tension, before we apply the force, our force. Okay, the closed length. In the estimation manual, he calculated the free length, and also he said maybe you can also say it is we can add this diameter, okay, the wire diameter from here and the wire diameter from here, but usually we deal with the free length. Okay, so we calculate L naught, yani that is the first requirement in the question. So in order to calculate L naught, we will use this equation. L naught is equal to this equation. So let's write this equation. This 2 times D minus D small plus NB plus 1 times D. Okay, D and D small, nothing is mentioned in the statement of the question. Only what was mentioned is NB, so I have NB. So what about D and D small? D small, he gave you the figure. D small is this value. Okay, it is the wire diameter. It is 0.162. So it is clear for me that the wire diameter D small is equal to 0.162 inch. Okay, what about the mean coil diameter? Mean coil diameter, I have it is given the question. It is in the figure I can see this one is the outer diameter. Okay, and I know that in order to find the mean diameter, mean coil diameter, I can use this equation that the mean coil diameter is equal to the outer diameter minus the wire diameter. So I will use this equation in order to find the mean diameter. So it is D is equal to outer diameter minus the wire diameter. It is equal to the outer diameter is 1.5. Okay, it is here 1 and 1.5. It is 1.5 minus the wire diameter 0.162, and this will give me that the mean coil diameter is 1.338 inch. Okay, so now I can find L naught. So L naught is equal to 2 times 1.338 minus 0.162 plus 84, the number of body coils, plus 1 times the wire diameter 0.162, and this will give you that L naught is equal to 16.122 inch. Okay, if we use the other equation to calculate L naught is equal to 2c plus minus 1 plus NB times small d, and this will give you 2. C can be calculated. It is the ratio, the spring index between the mean coil diameter over the wire diameter. The mean coil diameter is 1.338, okay, and the wire diameter is 0.162. So this will give you 8.26. So times 8.26 minus 1 plus NB given in the question 84 times D 0.162. Okay, this will give you also the same value, 16.122 inch. Okay, that is for the first requirement, part A. For part B, find the torsional stress in the spring corresponding to the preload. So TI, okay, corresponding to the the preload, the initial tension. So it is TI, and it is only TI, or can say it is uncorrected because we didn't check if it is in the preferred range or no. Okay, so it is equal to KB 8FID over pi d cubed. So TI, or TI uncorrected, is equal to KB the factor for the correction factor for the curvature, okay, times 8 Fi over d pi d cubed. I have everything, but I don't have KB. Okay, KB its equation is 4c plus 2 over 4c minus 3, as you can see in the equation sheet and in the previous from the previous video also. The Bergstrahl factor KB 4c plus 2 over 4c minus 3. Okay, so 4 times 8.26 plus 2 over 4 times 8.26 minus 3. This will give you that KB is equal to 1.166. Okay, so the TI, the uncorrected shear stress, is equal to 1.166 times 4 times 8.26. No, 8.26. No, this one is C. 1.16 times 8, okay, times Fi is 16 given the question, times D 1.338 over pi d cubed, d small is 0.162 cubed. Okay, this will give you that the TI uncorrected is 14951 pound squared inch. Okay, that is for the first part. And if you want to check, if he asks you to check if it is in the preferred range or no, you can use the equation that we used in the previous video, or you can use the graph. The spring index is 8.26, so something here, and the shear stress is around 14.9, so it is, yani, you can say it is in the preferred range also. Okay. The third part, part C, estimate the spring rate. Spring rate K. Okay, the spring rate or the scale of the spring is K. I have everything, but I want to calculate NA, which is equal to NB plus G over E, and I want also to calculate G. So G and E can be found from table 10.5 under the oil tempered row, and solution manual didn't use this row, and that's wrong. They used the one for the hard drawn spring, and they care about that the diameter is larger than this value 0.125, the wire diameter. Okay, but actually our material is not hard drawn spring, it is oil tempered. Okay, so the correct solution is to use this row. Okay, so and at these materials under the hard drawn, we don't care about the wire diameter, what is the dimension for, or the long for the wire diameter. Okay, so we will take the values for E and G to be 28.5 and 28.5 here. Okay, 28.5 and 11.2 from this row. Okay, so first, in order to find K, I need to find NA, and NA is equal to NB plus G over E. Okay, so NA is equal to NB plus G over E. G and E is, G is 11.2 megapound per square inch, and E is equal to 28.5 megapound per square inch. Okay, NB is given the question 84. The ratio between these two are 11.2 over 28.5, and this will give you that NA is equal to 84.39. Then I can find K from this equation, d power 4 G over 8 d cubed over NA. Okay, d power 4 is 0.162 power 4. G, I have to put it in pound squared inch, so I have to multiply by 10 to the power 6 to cancel the mega. So it is times 11.2 times 10 to the power 6, because I want the K value to be in pound force per inch. Okay, over 8 times 1.338 cubed times 84.39. Then K will equal to 4.77 pound force per inch. Okay, that is for the for part C. Okay, for part D, what load would cause permanent deformation? The permanent deformation means plastic deformation. Okay, after the elastic region in the stress strain curve. Okay, so if we draw the stress strain curve, it will be something like this. That is the elastic region. Then we will have something like this. Here is the yield strength. Okay, whatever it is SY, or if you are representing the shear yield strength, here it is the yielding point. Okay, yield point. Okay, anything before this yield point, if you deform or you make a tensile for the spring, it will, and leave it, it will return to its original shape again. But if you applied a stress above or has a higher value than the yield point, okay, the yield strength, then you will cause a permanent deformation. In this region, okay, this region is the permanent deformation for the spring. Permanent deformation, okay, in the plastic region. But here at this region, it is the elastic region. Okay, there will be no, the spring can return to its original shape. Okay, so in order to find the load means force. Okay, the force that is applied to the spring. Okay, we have to calculate the force at this point, because after this point we will have permanent deformation. Before this point we will have elastic deformation. So at this point the permanent deformation will start. So he is asking me for this point, what is the force or what load will cause permanent deformation. Okay, so I am comparing between that my stress will يعني exceed the yielding strength. Strength is a property of the material. Stress is the يعني the load will cause a stress. يعني you apply the stress, but the strength is already from the material itself. So if you exceed the strength of the material by applying a stress, you will cause a permanent deformation. And this happen at this point in the factor of safety for the body coil is equal to 1. NA at point A for bending and axial load is equal to 1. NB at point B is equal to 1. Okay, as we saw in the previous video when we talked about N, NA, and NB. Okay, and N is already what? And the factor of safety is what? Is يعني a ratio between the strength and the stress. Okay, so N is equal to SSY over tau max, N is SY over sigma A, NB is SSY at point B over tau B. Okay, when this one is equal to 1, this means that SSY is equal to tau max. Okay, meaning at this point, after this point, if tau max is increased a little bit, you will cause a permanent deformation. Okay, also here, SY equal to sigma A when N is equal to NA is equal to 1. If you increase sigma a little bit above the strength of the material, you will cause a permanent deformation. The same thing will happen if NB is equal to 1, SSYB, the tau B, if you increase it, you will have a permanent deformation. Okay, so يعني he is asking me for F max, and as you can see from the equation for tau B and for tau max and for sigma A, all of them contain F max. At this, يعني he is asking for F max because if I apply this force, okay, I will exceed يعني the yielding and I will cause a permanent deformation. That is the maximum force that I applied, that I will apply, and before يعني at the end of the elastic region, I will cause permanent deformation by applying this force. Okay, so I want to compare F max from here and F max that I will calculate from here and F max that I will calculate from here. Okay, I want to see what is the minimum force between of these three. F max that I will calculate from here, F max from here, and from here, because the minimum one means that يعني يعني the stress will happen first, or the yielding will happen first because of this type of stress. يعني if F max for bending is the minimum, means that the yielding will be exceeded by the bending stress before the torsion, the shear stress will exceed the what is this one? SSY is the shear torsional shear strength. Yes, okay. يعني meaning that sigma will exceed the yielding before the tau and other tau will exceed the SSY. Okay, so the minimum is the load that he is asking about that will cause the permanent deformation. We will see. We will repeat it again, inshallah. Okay, so without permanent deformation, tau max, which is equal to KB, tau max for the body coil, KB for the Berger factor, this one is times 8 times F max D over pi D cubed. For the elastic region without permanent deformation, it must be less than or equal to SSY. I care about the equal because it is the critical point here. After this point, I will cause a permanent deformation. Okay, and also for tau B, it is equal to K at point B times 8 F max, and these F max are different. يعني this will give me a value for F max, this will give me a value for F max, because tau B will not equal to tau max, and SSY for this one not equal to SSY at point B. Okay, over pi D cubed is then SSY at point B, and this one sigma A is equal to F max and also this will give me a different F max than these two. Okay, times K at point A 16d over pi d cubed plus 4 over pi d squared. This one also in the elastic region without permanent deformation will be less than or equal to Sy. At the equal, if I exceed this equal, okay, if the stress is larger than the strength, or the shear stress is larger than the torsional shear strength, then I will have permanent deformation. Okay. The minimum value that I will obtain, the minimum value between these three values for F max is F max, or the one that will cause the permanent deformation. Okay, so in order to find all of them, okay, I need to find SSY, because I will consider that SSY is equal to tau max. I will take the equal case, okay, because that is the critical point for us, okay, and find SSY, SSYB, and SY. This value, I want to find them from the table, this table, okay. I will use this percentage at tempered. It is oil and quench and tempered wire, okay. But in order to find them, I need to find first SUT, okay, before I multiply by the percentage. And SUT can be found from this equation, and this equation I have the wire diameter, but I need A and M, and A and M can be found from the table at this row for oil quench and tempered wire, okay, with kilopound per square inch. Okay, also let's find the SUT. Okay, SUT is equal to A over D power M. A from the table is 147 kilopound per square inch times N power M, and M is 0.187. So the unit of A is kilopound per square inch times inch power 0.187 for this case. Okay. So this one is 147. The wire diameter is 0.162 over power 0.187, and this will give you 206.6 kilopound per square inch. Then I can find SSY, SY, and SSYB by multiplying by the percentage from table 10.7. Okay, from the left column, I will take last time in the previous video we took 0.45. let's take here 0.5. okay. In the right column we'll take 0.75 to calculate SY, and for the end coil at point P, for the end of the hook at point P, SSYB will equal to 0.4 times SUT. Okay, so let's find them. So SSY for the main body, for the coils, is 0. I'll also take here 0.45. Let's take 0.45 because I calculated everything based on 0.45. Okay, so 0.45 times 206.6 equal to 92.97 kilopound per square inch. SY is equal to 0.75 times 206.6 SUT, and this will equal to 154.95 kilopound per square inch. And SSY at point B is equal to 0.4 times 206.6, and this will give you 82.64 kilopound per squared inch. Okay, now after I found all of them, I said we will take the equal case because it is the start of the permanent deformation. Okay, so tau max will equal to SSY because we said N will equal to 1, NA will equal to 1, and NB will equal to 1. خلاص. Okay, because it is the starting for the permanent formation. Okay, and this will equal to KB times 8 F max D over pi D cubed. Okay, SSY we calculate to be 92.97, and it is in kilopound per square inch, so I have to multiply by 10 to the power 3 because I want my F max when I calculate it to be in pound force inch. Okay, 10 to the power 3. Okay, so KB is 1.166. This we calculated KB at the beginning. Okay, times 8 F max. I want to find F max times D is 1.338 over pi. D is small d is 0.162 cubed, and then F max, let's say for the coil of the main body, is 99.493 pound force. Okay, now that is for the main body. Let's go for point B. Okay, I will take the equal case. Okay, in order to find this one, the F max from this one, I need to find KB first. KB at point B, it is different than KB only KB. Okay, so KB K at point B is equal to this equation. KB K at point B is equal to 4C2 minus 1 over 4C2 minus 4. Okay, and C2 is equal to 2R2 over D. Okay, so let's see R2. He didn't mention anything about R2 in the question. Okay, I used this use this equation for KB. Okay, and C2 is 2R2 over D, and this KB at point B is not like KB that we used for the main body. Okay, so really, what is R2? Yani R2 at the previous video we said it is from the center of this curvature to the center of the wire. Okay, so at this question, okay, he has a mistake in the dimensions that he gave me. Okay, he gave me that this one is half-inch radius, and when he looked from the top, he said it is a quarter. Okay, so this one should be 1 over 4, or you change this one to be half. Okay, we will make it 1 over 4, both of them 1 over 4. Okay, now this 1 over 4 is just it will end at this point. Okay, it will not go to the center. Okay, but my R2 should go inside until the center of the wire. You must add D over 2 also. So I will take this value, which is 1 over 4, to here. Then I will add D over 2, 0.162 over 2, in order to get R2. So R2 is equal to 1 over 4, okay, plus D over 2. Okay, this R2 is equal to 1 over 4 until the beginning of the wire to the center of the wire. So R2 is equal to 0.25 plus 0.162 over 2, and this will give you 0.1 0.331 inch. Okay, for R1 we already know that R1 is equal to D over 2. Okay, so we already calculated D to be at the beginning 1.338, and if we divide it by 2, then R1 will equal to 0.669 inch. Okay, so it must يعني R1 and R2 must end at the center of the coil of the wire. Okay, so now I can find KB and K. So for this one, R2 is 0.331 over D is 0.162, and this will give you that C2 is equal to 4.086. Okay, then I can calculate K at point B. 4 times 4.086 minus 1 over 4 times 4.086 minus 4, and this will give you 1.243. Okay, now I can use this equation, okay, to calculate F max at point B. So I will say that tau B is equal to SSY at point B and equal to 8 F max D over by D cubed. Okay, we have to multiply, there is KB, right? Yes, there is KB here. Okay, so we have to add KB. Okay, KB is 1.243 times 8. F max, I want to calculate F max. D is 1.338 over pi, D is 0.162 cubed. I didn't calculate this one, so let's use the calculator. 1.243 times 8 times x, 1.338 over pi of 0.162 power 3, and this is equal to tau b. We got tau b from here to be, we said it is equal to SSYB, and it's equal to 82.64. So right here 82.64 times 10 to the power 3 because it is in kilopound per square inch. So this one is equal to 82.64 times 10 to the power 3, and this will give you that F max is equal to 82.95. 96. Okay, bound force. Okay, that is, let's call it F max for the end hook torsion. Okay, okay, now the remaining is what is to calculate for the yield strength sigma A. Okay, so we will say that sigma A is equal to Sy and equal to F max K A times 16 D over pi D cubed plus 4 pi D squared. Okay, Ka depend on C1. C1 is equal to 2R1 over D. R1 we said it is D over 2, D capital over 2, and we calculate it to be 0.669. D small is 0.162, and this will give you 8.26. Okay, K at point A, the stress the factor that consider the stress concentration for the curvature يعني. Okay, if he ask you exactly what's the meaning يعني, or يعني he said in the question calculate the stress correction factor for curvature, you can use this equation for KB and also for KA. Okay, so KA is equal to 4C1 squared minus C1 minus 1 over 4C1 C1 minus 1. Okay, 4 times 8.26 squared minus 8.26 minus 1 over 4 times 8.26 times 8.26 minus 1. Okay, then K is equal to 1.099 Ka. Now I can say that sigma A is equal to Sy and equal to F max K point A times 16 d over pi d cubed plus 4 pi d small squared. Okay, Sy is 154.95 times 10 to the power 3 because it was in kilopound per square inch. I want to calculate F max, and Ka is what? Ka is 1.099 times 16 times d is 1.338 over pi d small is 0.162 cubed plus 4 over pi 0.162 squared, and this will give you that F max at point A, let's say, it is equal to 85.6 pound force. So I have 85.6 pound force, and I have also 82.95 pound force, and also 99. So 99, it is not the minimum force. The minimum force is caused by end hook torsion. Okay, in the solution manual, here, first they used G and E for hard drawn. Okay, that is the first thing. Also, because of this, the answer at the end will be that F minimum is caused by the bending. Okay, because of the Fa. But here for our case, because we used for the row of the quenched and tempered oil steel, it is the minimum force is for end hook torsion. Okay, to 82.95 pound force. So that is the force that he asked for. That's this the minimum force that this one that will cause the minimum or the permanent deformation. Okay. And finally, the last part, what is the spring deflection corresponding to the load found? So يعني he wants to find Y max, and Y max is equal to F max that we calculated in part D, okay, minus Fi over the spring rate K. Okay, so for this part, Y max, which is equal to F max minus Fi over K. F max is now what was the value for F max is 82.95 minus 16. K is 4.77, and this will give you, let me see the calculator, 82.95 minus 16 over 4.77. This will give you 14.035 inch. خلاص, and that is for this question. We finished these parts, and we didn't find any questions. If I didn't find any question other these two questions. So if you have any other question, just write it in the description or send it to me, and we will make another video about extension springs, inshallah.